Friends, today's subject of discussion is Pinner pyrimidine synthesis. This synthesis of pyrimidine heterocyclic molecule was given by the researcher Pinner. He identified in year 1880 that amidine reacted with ethyl acetoacetate to give an heterocyclic molecule pyrimidines. Later, the ethyl acetoacetate was replaced by n number of other 1,3-dicarbonyl compounds like malonic esters, beta diketones, etc. And this reaction to occur, it requires either an acid or a base as a catalyst. Ethyl acetoacetate, CH3CO, CH2COOET reacts with amidines in the presence of an acid to give rise to pyrimidine derivative. How this reaction occurs? Let us look into the mechanism. Ethyl acetoacetate in the presence of the acid, H plus, it acts as an electrophile. In the presence of this electrophile, electromeric effect occurs and the pi electrons moves towards oxygen owing to its electronegativity. That's why it is electron rich. This, as it is electron rich, as it moves towards oxygen, it becomes monovalent. It has to maintain its divalency for its stability. That's why these excess electrons, it donates to proton given by the acid. And thus, the protonation of the carbonyl oxygen takes place. As these pi electrons are moved towards this oxygen, the carbon has become electron deficient, creating a positive center on this carbon. Onto this positive center, the amidine reacts. The amino group, as it is the nitrogen in sp3 hybridized form, it has lone pair of electrons. This is electron rich and this is electron deficient. As we know, unlike poles attract each other, the reaction occurs. The electrons are donated to this carbon and a bond is formed between carbon and nitrogen. Already, it has to maintain its valency, that's why OH gets kicked off. What will I get? Dehydration has occurred, H plus here and OH minus, they combine together to leave as water molecule and a carbon-nitrogen bond is formed. Now, the pi electrons moving towards the electronegativity of the nitrogen, it moves towards nitrogen, creating a negative center on nitrogen. The carbonyl carbon here is a positive center owing to the electronegativity of this oxygen, which is adjacent to this carbon. Thus, the bond is formed between carbon and nitrogen and it has to maintain its tetravalency for its stability, and ethoxy, as is a living group, it gets kicked off. I lose H plus and ETO minus as ethanol and I'll get a cyclized ring system. As the pi electrons are moved towards this nitrogen, this carbon has become positive. To satisfy the positive center over here and here, the pi electrons moves, the carbon hydrogen bond breaks, the nitrogen hydrogen bond breaks and the pi electrons moves towards this positive center to satisfy the positiveness of the carbon. respectively. Then this undergo tautomerism, nitrogen hydrogen bond breaks, and these electrons are shared between the adjacent carbon owing to the positivity of this carbon, and it has to maintain its tetravalency. Pi electrons moves onto oxygen, O minus, it combines with this H plus and it becomes its enol tautomer, and I got a pyrimidine derivative. This is spinner pyrimidine synthesis. Next class we can deal with the other heterocyclic compound synthesis. Till then, have a nice day. Thank you.